Hi everyone! Today we'll be walking through LeetCode problem 20, valid parentheses. Alright, so before we get started, you can pause and read through the problem statement and get a good sense of what the problem is actually trying to ask. So we'll go through examples 1 and 5 together. So example 1 here states that the input string is an open parenthesis and a close parenthesis. So let's go through the different checks that you have to do to ensure that the string is valid. So the open bracket must be closed by the same type of bracket, so we can see that these are both parentheses, so that's valid. Open brackets must be closed in the correct order, so that's also valid because our open parenthesis is immediately being closed by the closed parenthesis. And every closed bracket has a corresponding open bracket of the same type, so we can also see that's valid over here because our open parenthesis is closed by that closing parenthesis. So all three checks have passed, so this will return true. Now let's look at example 5. So example 5 has our input string of an open parenthesis, open square bracket, close parenthesis, close square bracket. So again, we'll go through the three checks. So open brackets must be closed by the same type of brackets. That's going on over here and here. Open brackets must be closed in the correct order. So what this means is the types of brackets, the pairs of brackets cannot fall in between each other. So as the open brackets open up, they must be closed in the reverse order. So if we wanted to make this valid, we would have to open the parenthesis, open a square bracket, close the square bracket, and close the parentheses. So that's a rule of thumb that we need to follow for this problem. So immediately we know that this check has not passed, so we can return false. We can look through the last check anyways just to see if that would become valid, and every closed bracket has a corresponding open bracket of the same type, so that is valid. But because it does not qualify the check 2, it will return false. So now let's kind of think through some intuition. So we know that the open parentheses need to be closed by the closed parentheses in the reverse order. So we need to make sure that we are checking the last open parentheses that we see in our input string to make sure it is being closed first. And the way we can do that is by using a data structure called stacks. So let's go through how stacks work. So stacks are a little bit intuitive in the sense that they mean exactly what they are. So for stacks, you can only add elements to the top of the stack, and you can only see what's going on at the top of the stack. You can only see the element at the top, and you can only remove elements off the top. So imagine a stack of books, right? If you're trying to get to this book over here, the only way you can do that is by taking books off the top to access that specific book that you're looking for. So the same way, you can only access the top of your stack. That's why we call it a last in, first out kind of data structure. So let's see how this specific data structure is relevant to this problem with a specific example. So let's take the example, open parenthesis, open square bracket, open curly brace, close curly brace, close square bracket, close parenthesis. So we know that this is a valid input string because open brackets are closed by the same type of brackets, they're closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So let's see how a stack works in this situation. So as I parse through my string, I'm going to use zero indexing. I am going to store all of my open brackets inside of my stack. So I'm going to start building my stack. So as I go through each of these elements, I am just going to add them into my stack. So I'm on index 0 over here, which is an open parenthesis, so I'm going to add that to my stack. Then I encounter an open square bracket over here. I encounter open square bracket, so I'm going to add that to my stack. And then I encounter an open curly brace, so I'm going to add that onto my stack. Now, I'm going to start parsing through the closed parentheses. And I see that I have a closed curly brace right here. So I'm going to look at the top of my stack, and I'm going to be like, okay, is that the right kind of bracket that it's being opened by? Yes, it is. So I'm going to pop the top of my stack, and I'm going to move on. So next I have this closed square bracket. Again, I'm going to look at the top of my stack, and I'm going to be like, okay, is that corresponding to the closed bracket that I'm on right now? It is, because they're both square brackets. So then I'm going to pop that off. Finally, I'm going to go to my last element inside of my string, and I see that's that's a closed parenthesis. So I'm going to look at the top of my stack to see, is that an open parenthesis? It is. So I'm going to pop that off my stack. Now I'm at the end of my string. My stack is empty. So I'm going to return true. So that's kind of how the intuition for this problem works. So now let's go through why a hash table might help with this problem as well. So the way a hash table works is I'm going to be storing all of my key value pairs as open and close brackets. So one of my elements is going to be an open parenthesis, and it's going to be closed by a parenthesis. So my key is going to be the open parenthesis, and my value is going to be the closed parenthesis. Then I'm going to continue to do that for all of my other elements over here. So this is going to be my hash table, and the way the hash table will work is it's just going to make that looking kind of easier. So when I go through the same example that I went through before, I'm just going to go through it super quickly in terms of how the hash table will work. So I'll store this in the corner over here. So now let's go through the stack again and talk about how the hash table comes into the picture. So again, if I'm parsing through my string over here, I'm going to go to index 0. I see that's an open parenthesis, so I'm going to store that into my stack. I'm going to do the same for all the open parentheses that I encounter as I go through my string. Now I'm on the first close parenthesis. So now I'm going to look at the top of my stack, and I immediately as a programmer know, yes, these are two parentheses that match each other. They're both curly braces. But your program does not know that. Your program will do exactly what you tell it to do, which is where the hash table comes into the picture. So now, when I look at the top of my stack over here, I'm going to go to my hash table, and I'm going to be like, okay, that's my key. What value does it correspond to? It corresponds to this kind of curly brace. Again, you know this as a programmer, but your computer does not know this. So the hash table then is going to say, okay, this is my value. Does this value correspond to the value that I'm looking at in my string? Yes, it does. Now, all of these qualifications have passed, so now I can pop it off my stack. So let's do this with one other example so you can kind of get a hang of using that hash table. So now we are on this closed square bracket. So we're going to look at the top of our stack. We're going to see, okay, that is a closed square bracket. We know that it works. The program does not know. So now we're going to send this over to our hash table. We're going to check, does this key match to the value that I'm looking at in my string over here? It does. So now I am going to pop this off. So you can keep doing this so on and so forth, but eventually you will clear your stack, you'll get to the end of your string, and you'll be like, okay, all my open parentheses have been closed by the corresponding type in the right order, so I am going to return true. So this is how the intuition works in terms of just working through it as a programmer, and then kind of thinking about how you can add a hash table into your mix and just make it a little bit easier for yourself, make that parsing a little bit easier. So now we're going to go ahead and we're going to code this out. All right, so let's go through the coding for this problem. So right off the bat, I've created a hash table. I've named it brackets, and it's a character for the key value pair. And there are 3 different entries in this hash table, each for the parentheses, the curly brackets, and the square brackets. So first thing we'll want to do is we want to insert the opening parentheses onto a stack. So I'm just going to name the stack opens. Next thing we want to do is we want to actually go through the input string, and we want to do different things based off of the types of brackets that we see. So if we encounter any kind of opening bracket, so here we have the open parentheses, we have the opening curly bracket, and we have the opening square bracket, we want to push that into our opens stack. So the only way we do that is by saying opens.push C. Now, if we encounter a closing bracket, so we're just going to put another if statement, and we're just going to change the type of bracket that we see. We want to check for a couple of different things. If we ever encounter a kind of input that only has closing brackets, so if we have something like this, then there are no opening brackets that correspond to these closing brackets, which means our stack is going to be empty. So if opens is empty at this point, or now comes the situation where we'd have to actually check our hash table to make sure that the closing bracket matches the opening bracket. So the way we do that is by saying brackets at opens.top. So remember, opens.top is the last opening bracket that we saw. So we want to make sure that the closing bracket we're seeing right now is matching the opening bracket that we just saw. So if that is not equal to C, so if that's not equal, so if it's not linking up in our hash table with the current closing bracket that we are seeing, then we want to return false. Now, we want to pop the top of our stack if it does not return false at this point, because if we pop the top of the stack, now we can start to see if there's still more opening brackets inside of our input string, and we can keep going on in the string. The last thing we'll want to do is we want to check if opens is now empty. So suppose we had a string where we had more opening brackets than we did closing brackets. So let's say we have something like this, where we don't have this last curly brace that's there, then we know that we are going to have a non-empty stack. So there's still going to be things in our stack, even though we go through the entire string, because we have this final curly brace that's there. So our stack is going to have this final curly brace that's there, which means that it's going to be an invalid string. So we want to return whether our open stack is empty. So remember that opens.empty is a Boolean, so if it is empty, it's going to return true. If it's not empty, it's going to return false. All right, so the last thing we'll do is we'll do the time and space complexity analysis. So we'll start with the time complexity. So the time complexity, again, is essentially how much time in Big O notation will this algorithm take to execute? So because we have this for loop over here that goes through every character of the input string, we know that the for loop will run n number of times, where n is the number of characters in the string. So the time complexity will be O of n. Now, if we look at the space complexity, we can see over here that we have a hash table that is a constant size. So because the hash table will always have a size of 3 entries regardless of the example or regardless of the test case that you use, it's going to be O of 1 over here. But if we look at the stack over here, which is opens, it will have as many as characters as there are opening characters in your string. So if you had a string of only opening characters, so something like this, then the stack would be the same size as the number of opening characters in the string. So that's why the stack size will be of size n. It can go up to size n. So we always consider the worst case scenario. So the space will be O of 1 plus O of n, which is just equal to O of n. So that's all for today's video. Thank you so much for looking through. Let me know if you have any feedback in the comments below, and make sure to like and subscribe for more LeetCode videos. See you next time.